Hi everyone, welcome back to Cloud on Air. My name is Jay Jenkins. I'm a customer engineer based here in Singapore. I hope that you've enjoyed the sessions that we've already had today. If you're just joining us, don't worry, because we're actually going to repeat all of those sessions for you this afternoon and this evening. So, what I'm going to cover is an overview of Google Cloud Platform. In about an hour, Dambo is going to come in and talk to you specifically about Compute Engine. Then after that, we have Ammo talking about data processing. Then we have Yoshi coming in and talking about how you can integrate G Suite with Google Cloud Platform. And finally, we have Mark Fong talking about networking on Google Cloud Platform. So first, let's go back to sort of an overview. And really, the goal here is to give you a broad overview of Google Cloud Platform and what it has to offer. What I'm not going to do at this point is do deep dives on each particular product. But as I said before, there are going to be some sessions later that are going to deep dive on specific instances, and I'll try to call those out as I go through this presentation. So in order to talk about Google Cloud Platform, I really need to go back to the beginning. So google.com, right? Searching through the internet, on average using 3 words to find exactly what you want on the first page of results and giving you that answer in milliseconds. Whenever you go to google.com, you expect it to be up. You never see a message that says, scheduled for downtime, doing an upgrade, please come back later. And what we really want to do with Google Cloud Platform is give you that same capability. I don't know about you, but whenever I connect to Wi-Fi, the first thing I do is I go to google.com. Not necessarily to do a search, but because I want to make sure the internet is up. Right? So it's more likely that it'll be disconnected from the internet than google.com will be down. But Google isn't the only product we need to build for. In fact, we have 8 products with over 1 billion users. You'll see a few familiar icons here. Things like Google Chrome, Android, which actually has over 2 billion users, YouTube, which serves over 1 billion hours of video every single day. For an individual, I would need to, for 1 billion hours, I would need to watch 114,000 years worth of video. And we also have Google Cloud Platform, which serves our customers' customers and has over 1 billion users as well. And in order to support that, we need a vast amount of infrastructure. And in fact, we've actually had to create new types of software, services, and change the way that we do our operations in order to support our customers and our customers' customers. So first of all, let's look at Google from an infrastructure perspective. So across the globe, we have regions. So here in green are the regions that have launched. In blue are the regions that we're launching. And in fact, since the last time we had Cloud on Air, which was back in May, we've launched 3 brand new regions: Singapore, Sydney, and London. Over the past 3 years, we've invested almost $30 billion in CapEx in order to make sure that we have regions which support our customers and also a global network which supports our customers. So let's take a look at that network. Google has the largest backbone in the world of any cloud platform provider. Many years ago, we decided that we needed to invest in fiber in order to get our services to our customers. Today, all of Google Cloud Platform's customers get to take advantage of that. And in fact, this year, we announced new fiber which we're laying between Singapore and Sydney in order to connect our data centers, in order to better connect our customers to their customers. And as I said before, we've had to invent a lot of new types of software. So you might recognize some of these, things like MapReduce. And down on the bottom right hand, things like TensorFlow. And these are sort of 2 ends of a spectrum of innovation that we've done, things that we've invented in order to crunch through large amounts of data quickly and deliver those services to our customers. But this just isn't a Google problem anymore. The idea of big data goes into all industries. And what we want to do is we want to make our platform available to everybody else. So Google's infrastructure for everybody. If we take a look at our open research, you can see that a lot of open source products have come out of that research. So things like Hadoop, things like HBase, Apache Drill, Crunch, and Apache Beam, and also Kubernetes, which is based on Docker containers. Years ago, Google were using containers internally in order to provide services for our customers and to provide reliability. And I'll talk more about containers in a little bit. Here's a quote from Doug Cutting, who is the Hadoop co-creator. Google is living a few years in the future and sending the rest of us messages. And primarily that was because we were running into those problems first. That said, that is no longer true anymore. Our customers are also running into those issues, and we want to be able to get our products that we've created internally, operations that we've created internally, and get those to our customers so that they can remain flexible, innovative, scalable, and reliable. And so you'll see that over the past few years, we have provided platforms for the same services that we are using internally. And these services are available to our customers in order to help them scale their operations. So if you take a look at the icons on the screen, it might be a little bit overwhelming. And in fact, there are a lot of products here, and as I said, I'm not going to be able to cover a lot of these in depth. But my goal here today is to introduce you to some of the primary concepts and also have you think about where you are today, what you might need to build in the future, but make sure that you can do that in a way that allows you to move to the cloud quickly. So you can see I've grouped these tools into several large groups. Things like compute, big data, networking, storage and databases, developer tools, management tools, and of course things like machine learning, which are all available on Google Cloud Platform. Some of these we're going to talk about more in depth today. So we've got sessions around compute, around networking, around big data, and we also have integration capabilities between G Suite and Google Cloud Platform that we'll talk about as well. So broadly what I'm going to cover is computing. So how do I do things on Google Cloud Platform? Networking, how do I connect those things? Storage, so how do I store my files? How do I store my data? Big data, once I have that data in the cloud, how do I process that and how do I scale that? Administration, so how do I control how Google Cloud Platform is being used? Development, so how do I change my operations to be more of a DevOps type model? And finally, machine learning. So let's start with computing, doing things. So when I think about computing, I sort of think about this continuum of services that Google is able to provide. What we want to do is we want to think beyond simple virtual machines on your left, and then think more about serverless or serverless DevOps on your right. And Google provides a range of products, a continuum of products that can provide all of those things. So let's start with virtual machines. So virtual machines themselves, or on Google Cloud Platform, what we call Google Compute Engine, are exactly what you might think they are. You have an OS, you have a machine, you have capability to do things like SSH or RDP into those machines to get access, and you control things from an operating system level and can change those operating systems. You tell us the type of machine you want, how many processors, how much RAM. You provide persistent disk. And with persistent disks, you also have the capability to do things like have both standard persistent disk and SSD persistent disks up to 65 terabytes. You can also have local disks, local SSD disks up to 3 terabytes in size. You can also have things like RAM disks and file servers, on Google Cloud Platform. On the processing side, beyond standard CPUs, which you can put up to 64 cores on a single machine, you can also connect GPUs ad hoc to those machines. So at any time, you can shut down a machine, add GPUs, do some intensive GPU compute, and then disconnect those GPUs as well. And the great thing is, you're not constrained to standard configurations. So let's say that I wanted to actually have 3 CPUs on a machine. On Google Cloud Platform, you can actually build your own machine. You choose the number of CPUs, you choose the amount of RAM that you want to have on that machine, and build it accordingly. And these virtual machines spin up in tens of seconds. So they start up very, very quickly. In addition, you're billed by the minute, so not by the hour. So after a minimum of 10 minutes, so if I spin up something for 11 minutes or 12 minutes, I only pay for 11 minutes or 12 minutes. Just a couple of months ago, an MIT researcher actually spun up 580,000 cores of compute in order to do some high-performance computing operations. And he did that on a Sunday afternoon. So 300 years of compute in a single afternoon, and these were what we call preemptible VMs, which are at an 80% discount. So 300 years of compute for around $20,000. And that's the kind of flexibility the Google Cloud offers. So what if I want to use, what if I want pre-configured systems? Actually, we have something called Cloud Launcher, and I'll actually show it to you now. And Cloud Launcher actually has virtual setups that provide not only a virtual machine, but also networking capabilities, clustering capabilities, which are created by our partners to provide a one-click-to-deploy solution for your organization. So containers. So containers are a hot topic at the moment. But what are containers, and how do they differ from virtual machines? So what containers are they are essentially a virtualized kernel. So instead of installing your applications on an operating system, you have a container of services which has your binaries and all of their dependencies to make sure that those containers are portable between different operating systems, different providers. You can run them on-premise or even cluster them across different providers as well. And at Google, we have Google Container Engine, which is essentially managed Kubernetes. So what is Kubernetes? Kubernetes is a container orchestration system. And what it does is it allows you to run a large number of containers in production through declarative statements. So you might say, I want 100 of these microservices running at any time. If one of those microservices falls over, Google Container Engine will restart those services for you because it's based on Kubernetes. It also allows you to schedule jobs and to batch jobs. So again, imagine you have a full stack of services from the front end all the way to your data services. These microservices can be maintained and also bin packed onto specific machines to make sure that you're getting the most out of those machines. Now Kubernetes itself is open source, which means you can actually install this on-premise or on any sort of virtual machine cluster that you want. That said, you also have to maintain those clusters. Think about the updates. Think about the master node which controls each of those services. In addition, you also have to worry about your DNS server and service discovery, your logging and monitoring of those services. What Google Container Engine does is it allows you, with a single click, to actually create this container cluster and then create declarative statements which schedules the jobs on Google Container Engine. Google Container Engine will manage that master Kubernetes node to manage the containers which have been deployed. So Container Engine, which again is managed Kubernetes, containers as a service. And it has essentially defaults for things like monitoring, logging, DNS, and service discovery. And it has auto-scaling capabilities as well. If I sort of move more toward the serverless area, you also have things like App Engine Flexible Environment, which is a custom runtime where you can bring your own Docker file. And Docker file is just a container type. So you can either put those under Kubernetes, where it's more of a declarative statement, where you give it a bit more instruction on how you want those containers orchestrated. App Engine Flexible Environment is more for web type applications, where you can bring your own Docker file and we will auto scale that for you. For containers, we also have a container registry. So that works with GKE, which stands for Google Container Engine, only because GCE is Google Compute Engine. So you might think about it as Google Kubernetes Engine. And it also works with App Engine Flexible or with any sort of Docker type container. We also have a container builder. So if you have your own CI/CD setup where you actually need to build these containers, you can actually make that part of your workflow. It integrates with the container registry to place the containers into container registry when they've been built, and it will integrate with your build process. So I talked a little bit about App Engine Flexible Runtime already, but you can see the list of languages supported, but these are open capabilities. And essentially, if you can run it inside of a container, you can run it inside of App Engine Flexible Runtime. Just to the right of that, you see App Engine Standard Runtime. While it has a more limited number of languages that support and constrained capabilities, what it can do is it rapidly scales. So let me talk about that for a second. App Engine Flexible Runtime will scale it for you, and it will scale down to a single node. App Engine Standard Runtime will actually scale down to 0 because it takes milliseconds for it to spin up a new node and start answering requests. App Engine Flexible Runtime is dependent on your container, so it takes more time to instantiate that container, still in hundreds of milliseconds, but maybe not as performant as you like in terms of being able to scale up rapidly. App Engine Standard Runtime allows that rapid scale. If I look more at serverless type functions, we also have cloud functions. So what are cloud functions? So let's say that I wanted to create a discrete function to send an email. Instead of creating a microservice around that, I could or a containerized microservice around that, I could actually create a cloud function to send that email. And this can respond to events such as HTTP, and you can also have events off of, for example, cloud storage. So if a new object is stored in cloud storage, I can send an email. Or you could use it for things like Cloud PubSub, which is essentially a message queuing service. So if a new message comes in, I can send out that email. And it allows for massive reuse of that, but also massive scalability in terms of, again, if I'm not running it at all, I pay nothing. But as soon as I make that first call or thousands of calls, it will scale up automatically for me to service that function. So now let's talk about networking. So great, I've got my virtual machines there, or I've got my containers or App Engine. How do I connect these things together? Again, Mark Fong is actually going to talk about this more in depth later, but I'm just going to give you a broad overview. So I'll talk about this in three broad terms. One is connection, one is security, and one is availability in terms of networking. So first we have our cloud virtual network. So it allows you to create custom private cloud networks that are logically separated from other virtual private cloud networks. You can set up custom routes to non-Google locations as well. So this is essentially where your application sits and the services that it needs to talk to. We also have Cloud Interconnect, which is a dedicated connection to Google. And you can either directly peer with us at one of our local or regional points of presence, and we also have partners that provide interconnect services as well. So from a security standpoint, we do have VPN. So this isn't VPN in terms of I'm going to VPN into an instance as an end user. This is more about VPNing from a gateway to gateway standpoint. So extending my cloud functionality between two networks. We have firewall rules, and the great thing about firewall rules is you can actually apply this to tags. What tags allow you to do is apply those same tags to virtual machines. And if I have a firewall with a tag and I make a change there, the virtual machine with that same tag will get those updates immediately. So it allows us to control those firewall rules at a unified level. So what about non-managed security solutions? So if there are security solutions which Google Cloud Platform doesn't provide, first of all, Compute Engine itself is just a virtual machine. You can obviously build anything that you want to by hand, all the way down to the boot disk. But we also have other services. So I mentioned Cloud Launcher before. We have pre-built solutions from partners such as Barracuda, Brocade, and Cloudflare. So take a look, and there might be a security solution there for you. So now let's think about things in terms of availability. So Google does have a content delivery network. It's the same content delivery network that we use for our services. You can activate that through our load balancers, or you can use HTTP headers to determine the cacheability of those objects. We have a DNS, and this is probably one of the few cloud services you'll ever see with a 100% SLA promise. And Google also has load balancers. Again, Mark will talk about this in a session later, but these load balancers provide massive scalability because, again, these are the same load balancers that Google uses, which means there's no need to pre-warm these if your site all of a sudden becomes viral and needs to scale massively. So let's talk about storage, right? So actually, where do I put these objects, or these files, or where do I put my data? So let's think about that, again, in three different ways. One is pure file storage or object storage. One is databases. So where do I store that structured or semi-structured data? And the last one is more of a pivot on databases or data, which is around big data. So how do I take massive amounts of data and make some sense of that and make it accessible and useful for my organization? So first we'll start with pure object storage. And there are several different types of storage: multi-regional, regional, nearline, and cold line. And when I think about which ones I might be using for a particular use case, let's break it down in sort of three different types of things. Public content, so a website, for example, or static content on a website. Processed data, so something that I might be processing for big data, as an example. Long-term storage, so archive data, so all of my backups, all of my disk snapshots, scanned images, videos, anything that I need to push to long-term storage. If I take a look at that in terms of the characteristics, multi-regional storage actually stores that data in more than one region, which means, number one, you'll know that it's backed up someplace else. So if for some reason your user loses connectivity to one of the regions, they'll still be serviced from one of the other regions. Regional storage is stored in a single region, so it has lower availability, but and is normally used for smaller applications that don't need that availability, or applications which might be doing something like data processing where they only need that data accessed regionally. Then after that, you're looking at long-term storage. And you can see here there's a trade-off, because the storage costs will go down for long-term storage, and essentially you're paying for retrieval costs. And this is more for archival, but the latency on our long-term storage is extremely responsive and low latency. So whenever you request that object, it's available immediately. So now let's take a look at application data. So SQL data, NoSQL data. So for SQL data, or schema-defined information, we have Cloud SQL, which is a traditional SQL server, and it supports MySQL and Postgres. And it's essentially vertically scalable. Although you can scale it somewhat horizontally through the use of replicas, there is a limit to how SQL databases can scale. Google internally uses a product called Spanner, and we've made that available this year. Cloud Spanner is actually a highly available, strongly consistent, globally distributed, horizontally scalable database. Essentially, it's a SQL database for big data and massive amounts of transactions. It takes two things in order to have a product like Spanner. One is we have a global network that offers low latency across the globe, so that when I commit something here in Singapore, that I can get a consistent read across the globe in the United States. The second thing that we need is a way to know when a commit has happened. So just in case there's some sort of a conflict, the database can resolve that. And in order to do that, in every single data center, Google uses atomic clocks in order to get the true time of that transaction so that it can resolve the conflicts across the globe. The second thing I'll talk about are NoSQL databases, sometimes thought of as key value stores, but essentially these are more horizontally scalable databases, but suffer from things such as eventual consistency. But they still have their uses in terms of their massive scalability. So Cloud Data Store is a document-based key value store that allows for storage of your application's data and can horizontally scale that to multiple locations. That said, if you're looking for larger volumes of data which require extremely low latency, for example, an IoT solution, you'll want to look at something like Bigtable, which uses columnar storage and is HBase API compatible, which allows you low latency in terms of your writes and of your reads. And finally, let's look at big data. So where do you store big data? And really, this comes down to storing it the same place you store everything else. The difference here is, how do I make sense of what I've stored in other places? Or where would my data warehousing application be? For data warehousing, and I mean at a petabyte scale, we have a product called BigQuery, which uses a wide column store. And it allows you to use SQL on your data without having to build indexes, without having to worry about how it scales, without having to worry about the underlying infrastructure. So it provides an enterprise data warehouse in a serverless way. And it allows you to use standard SQL in order to query that data. So how do I make sense, though, of all that data? If I have data from multiple sources, or I'm consuming large amounts of data from click streams on my applications, as an example, Google has a number of tools available. So I mentioned PubSub before, which is essentially a messaging bus. And this allows a common publish-subscribe model, which can easily handle 1 million messages per second, and it is a global messaging bus. We also have a tool called Dataflow, which supports streaming and batch data. And again, this is more of a serverless type implementation in that you don't need to worry about how it scales. So if I'm streaming data and it has a peak in the middle of the day, I don't need to worry about growing that cluster or shrinking that cluster in order to handle that volume. Dataflow itself will actually manage those servers behind the scenes, manage the allocation of work, and parallelize that data and that work across those machines. And this is based on Apache Beam. So if you're already using Apache Beam today on-premise, you can actually take that model and implement it right away inside of Dataflow. And finally, Dataproc. Dataproc is actually going to be covered by Ammo in a separate session, or he covered it this morning. And what this is managed Spark and Hadoop. And it includes auto-scaling, but essentially you can bring your current Spark and Hadoop workloads to Google Cloud Platform, but use that in a managed service way. So there's a lot of services here, but the best way to sort of connect all of these is through PubSub, which is, again, that global messaging bus, or through something like cloud storage. And these services have native integrations to those services. All of these services also include a rich set of SDKs and APIs so that you can integrate to those from other sources as well, which I'll talk about in a moment. Okay, so what if I need something that you don't offer? So first of all, again, in Compute Engine, you can build all of that by hand. So that virtual machine is something that you can install, again, all of your custom libraries, a custom operating system if you want to. And the other one, which I've mentioned before, is Cloud Launcher, which has pre-built solutions, and again, not just virtual machines, but clusters of machines, networking configurations. So with a single quick click, you can have your application up and running. So an administration perspective, so operations. So how do I operate this? And again, I'll talk about this in three forms: reporting, security, and configuration. So reporting. So you're going to hear me talk a lot about Stackdriver for the next couple of minutes. Stackdriver is the one place where we do things like logging, monitoring, and debugging. In terms of logging, we offer cross-cloud logging, so we can log information from Google Cloud Platform or from Amazon Web Services, or you can even do that from on-prem with API calls. For monitoring, we offer monitoring services for Google Cloud Platform and AWS, and we have alerts off of logs, uptime checks, or your built-in custom metrics, and that can integrate with products such as PagerDuty. From a security perspective, we have cloud identity and access management. And if you're a G Suite user, this actually integrates with Cloud Identity. If you're not a G Suite user, Cloud Identity is available to you, so you can actually manage your organization. You can manage one-time passwords, you can manage security keys for access for your operations team and your development teams. Once you have that identity, you can actually manage groups of resources. So you can have separations of concern from your networking team versus your compute team, the team that takes care of your images, the team that takes care of your monitoring. It has role-based permissions at a fine-grained level. Also, from a configuration perspective, we have a command line interface which you can launch from our web interface. And it has tools like gcloud, so you can script things. You can actually script the entire deployment of your virtual machines. And things like gsutil. So gsutil actually connects with our Google Cloud storage facilities, and it allows you to move objects into and out of Google Cloud storage. We also have APIs, so SDKs for most languages, and REST endpoints for most of our, actually for almost all of our services that we provide. And it provides essentially a functional equivalent to gcloud. So anything that you can do from the command line, you can do via these endpoints. We also have Deployment Manager. So if you have extremely complex deployments which require templating, which require disk snapshots and disk images, and require complex network setups, you can actually use Deployment Manager to actually configure these so you have repeatable solutions. So what about development? So coding, reporting, and services that are available for development. So from a development perspective, again, we have our SDK, we have our gcloud and gsutil command line interfaces, and we also have app config, which allows you to interface with Google App Engine, which again is our serverless platform, or our platform as a service offering. We have plugins for your common IDEs, and we also have a cloud source repository, which means we have a place where you can actually store your source code. From a reporting perspective, again, coming back to Stackdriver tracing allows you to trace your application. This is automatic for App Engine and for load balancers, and it's enabled through our SDK for Java, Node.js, Go, Ruby, and Zipkin. And this links directly to the log files. So again, if you have an issue in one of the log files and you want to do a trace, you can click and actually see where that's happening in your code. We also have Stackdriver error reporting, which can actually aggregate the information from all of your applications into a single location. It's available, you can look at the logs directly, or we have APIs available so you can look at those errors. And again, we have alerts, which can link to things like PagerDuty to let your operations team know when something's gone wrong. Stackdriver debugging, available for App Engine and Compute Engine. And again, this allows you to debug live in the system. So Google Cloud Platform, however, aren't the only APIs and aren't the only services that Google provides. Google also provides a lot of other services, such as the Maps APIs, the G Suite APIs, the YouTube APIs. And we give you access to these APIs through the console so you can turn those on and make those available to your applications and to your resources that you've set up inside of Google Cloud Platform. And now I'll finally talk about machine learning. So machine learning is talked about a lot at the moment. I'll talk about how you can use, I can't go into in depth because there's a lot to learn. If you're interested in having a specific machine learning session, please provide us feedback on that. But I'll tell you how you can use the models on the platform, how you can create those models, and how you can extend those models for other services. So first of all, Google has pre-trained models for you to use. And those include things like the Vision API, where you can submit images and do things like face detection and label detection. We also have a natural language API, where you can look at a sentence, recognize entities in those sentences, and also do things like sentiment analysis. You can see how a user might be feeling, as an example, about your product. We also have a speech API, which does automatic speech recognition of 80 different languages. We have a translation API, which can detect the languages and actually translate between specific languages. And just launched this year, we have a video intelligence API, which can do things like label detection along the timeline in that video, and also do things like shot detection. It also has a safe search option so you can see if that video contains adult content. We also have Cloud Machine Learning Engine if you want to build your own models. Cloud Machine Learning Engine is essentially managed TensorFlow. So what is TensorFlow? TensorFlow is actually an open source machine learning library created by Google, and it allows you to build these models. TensorFlow also allows you to train the models across a distributed network of CPU or GPU compute. What Cloud Machine Learning Engine does is it provides you a managed TensorFlow platform. So you can create your model and then train your model using Google Compute clusters. And we'll scale that training for you. We'll help you tune the hyperparameters on that training, and we'll give you the model. Once you export that model, you can use it on your own systems. You can actually do the inference inside of Google Cloud, or you can even do that on a device, such as a mobile phone. So there's a lot of stuff here. And hopefully, events like today, Google Cloud OnAir, can deep dive into some of these tools. Again, if you'd like to know more about these tools, please give us feedback so we can schedule a session on the next Cloud OnAir to provide you a better layer of depth. Okay, so with that, thank you very much. And I'm going to bring Richard Coombs in here to ask me a few questions that you guys have been asking below.
Perfect. Thank you very much, Jay. Whenever I hear these kinds of sessions that cover everything in GCP, it kind of blows my mind how much there is. That last slide with 40 or 50 icons on it. It's so many different ways to sort of pull all this stuff together. So thanks for running through it. Lots of questions coming through. There's probably one or two that I'll try and remember, as well as the ones that we've stuck on the slide here. But let's run through those first, if that's okay.
Sure.
So first up, if we currently run a number of VMs on-premise, how do we figure out or work out which ones to move first? Kind of what's the process to follow?
Sure, absolutely. And really you need to think about, I guess, the boundaries of your application. But you also need to think about the structure of your application. So if it's a relatively new application or it's run using open source software and it doesn't have a lot of integration points with your on-premise systems, those become easier systems to move. So something like an externally facing website or a marketing website where it doesn't necessarily have deep hooks into your on-premise systems. After that, then I would look at some of those other types of systems. So again, if it has complex licensing requirements, if you can figure those out with those particular vendors and how it will be licensed on the cloud, if there are loosely coupled integrations with your on-premise systems so that you can make those calls from the cloud and understand how the integration works. And then there are other types of systems which you might not be able to migrate at all, and those include things that are built on customized hardware or older hardware, or things where a licensing agreement restricts your use of that software in the cloud. So with those, you're really going to need to think about how you might utilize the cloud moving forward and possibly re-architecting those for the cloud.
Yeah, I think that's good points in terms of theoretically thinking how you go about moving stuff. When it comes to technically moving stuff, I'm right in saying there's options and services provided by partners to actually help migrate virtual machines you might have running on premise that you want to move to cloud.
Yeah, absolutely. And I definitely recommend you stick around for Dambo's session on compute, and he'll actually talk a lot about that around migration of virtual machines into the cloud.
Perfect, thank you. Second question, which you touched on around sort of our networking and sort of setup of our projects and things, is around regions and zones. What are they? How are they different? Are they segregated, physically in the same place? Could you talk a bit more about those?
Sure, and then this comment actually came up around in the networking session as well.
Yeah.
So regions are essentially locations, and they're locations where Google has a data center, where we actually have clusters of compute. What a zone is it's a physically separated section of compute. So physically and logically separated so that the zones aren't dependent on each other.
Yep, running on different power sources, that kind of thing.
Exactly.
Perfect, thank you. So obviously a hot topic is security. As more and more enterprises and businesses are looking to move to the cloud, that's kind of one of the first questions is it as secure as what I'm doing now? So if they want to move to a cloud-based solution, how do we ensure that their data is encrypted? How can they have control over sort of encrypting and securing their data?
Yeah, absolutely. So I think the last count I heard was around 700 security engineers that we have working on Google Cloud Platform specifically around security. We also have a lot of professors as well. So academics that are working with Google, not only to take a look at security as it is today, but what security might look like in the future. It's interesting when you talk about security, a lot of people still think about things physically, right? And if sort of I know where it is, then it's secure. Again, people feel sometimes that their money is more secure underneath their mattress than it is in the bank.
Yep.
I think about that in terms of Google Cloud Platform as well. Really, number one is we would love to talk to you about your use cases, your compliance requirements, regulatory requirements, governmental responsibilities in terms of keeping your customer data secure. It's also important to understand that that Google is one of our largest customers as well in terms of Google Cloud Platform, and we do things like accept payments, so PCI compliance is important for Google Cloud Platform. We also have a number of third-party audits around some common certifications like ISO 27001, 27017, 27018 in terms of data privacy. And we also have things like our SOC 2 report, which talks about how we do things. So I also think it's important to understand that we have those third-party audits, so we do what we're saying. It's also a good thing to know about how Google stores its information. Everything we do in networking is actually encrypted in transit, and is stored encrypted as well. You can also bring, for many of our products, your own security keys. So you can either do customer-supplied encryption keys, or we can manage those keys for you to make sure that your data is safe.
Yeah, I think it's funny whenever I speak to customers who ask this question around security, if you throw it back to them and say, how are you currently doing security? And then we compare it with some of the things you just spoke about, whether it's hardware, custom-based hardware that we've got in our data centers, verified boot all the way up through the stack. It's kind of a stark contrast of kind of how important security is to Google.
And I think it's also important to know that you've got us as well. So customer engineers, again, we'd love to talk to you about what your requirements are. This is a shared responsibility, right? So it's not just about Google, it's about the entire solution that you're providing. And we want to talk about that architecture and how you can do that. So we have customer engineers in the region, we have solution architects in the region, and we also have specialty engineers which are purely focused on things like security.
Perfect, thank you. So next up, if I've got lots of data, how do I get it into the cloud?
Sure, so I guess it depends on what you mean by lots of data.
Correct.
It sort of depends based on specific customers. So if you just have a few terabytes of data, you can actually use Google Cloud Storage to just push that data. So something like GSUtil in order to do that. If you have things on other providers, we actually have tools which can allow you to move that content if it's in, for example, some other storage facility into Google Cloud Storage. Mm-hmm. But then there are customers that have truly massive amounts of data, right? So petabytes of data. And it's difficult to move petabytes of data. You can't just, you just can't use the internet, or you can't, use a USB key. Just, I'll just put that there and give it to Google. But actually, just last week, 2 weeks ago,
I think it was
last week. Yeah. So last week, we actually launched a transfer appliance, which you can actually put into your data center, into your rack, move the data onto that transfer appliance, and then move it to Google Cloud.
Great. Yes, I was reading that same launch announcement. So we've got either a 2U or a 4U based system, which is either 100 terabytes or 400 terabytes. If you then use compression as well, you can get up to a petabyte on a single transfer appliance, which is going to make moving it a lot quicker than putting it over a 100 meg internet line, for example.
Definitely.
So you talked about Kubernetes, Docker, containers, App Engine. Some of that can be quite confusing if you've not heard of it before. Mm-hmm. Can you sort of go through what each of those terms mean and how they relate to each other?
Sure. So as I mentioned before, a container is really just a collection of your binaries and their dependencies, which can then run on a virtualized kernel. And what that allows you to do is port that to different platforms. Docker is actually a type of container. Another type would be a Rocket container. And there are a couple different types of containers. And in fact, Google has been using containers for a long time. We actually have our own internal version of a container. Okay. But whenever we decided to open source Kubernetes, we looked at what the community was using. And in large part, that was Docker containers. And so we use Docker containers for Kubernetes. So Kubernetes actually does the container orchestration. So it takes a look at the containers and allows you to say, I want 10 of these Docker containers running all the time. Yep. If one of those Docker containers crashes, it will actually restart that container for you. So it auto-heals and manages that. It does a lot of other things as well. So it does things like service discovery. So if you have containers that are talking to each other, rather than worry about the IP address, it allows you to use the service name in order to communicate between those. I would say for Kubernetes, really the cheapest way or the best way to play with Kubernetes is just to use GKE, because it is a one-click deploy. Yep. So early on, whenever I started playing with Kubernetes, I actually did that on GKE, it made it really easy to click and play with that to understand how Kubernetes worked.
Right. I think one of the sort of aha moments for me, as I was first learning about containers and Kubernetes, was really around, if you're in your test or dev environment and you've set up your environment, there was always that headache of, now I need to move it to production. You think you've got everything running in production, but something goes wrong, and you're scratching your head. You're not, you think both environments should be the same. With containers, that headache kind of goes out the way. You literally can take your container and deploy it on different infrastructure, which is great.
Yeah, absolutely. And it also makes things like your CI/CD processes that much easier because you can do things like rolling upgrades.
Perfect.
So the last part of the question on App Engine Flex. So App Engine Flex allows you to use your Docker container, but again, that's really more focused towards web apps or a single API endpoint. Kubernetes actually provides orchestration across a number of microservices, so those microservices can actually talk to each other.
Great, thank you. And for this session, there was actually a number of questions around certification. How long is it going to take me? What do I need to do? Could you, I know that's probably an unfair question because everyone's slightly different with different backgrounds. Can you talk a little bit about what is the process and where to get started?
Sure. So you're certainly going to accelerate your time frame if you use things like the Coursera courses or the Quick Labs courses. Really the best thing to do, though, is to do the hands-on work with Google Cloud Platform. And we actually do have a free tier, so you can actually go in and play with these things at no cost. Because essentially, when you take that certification is really aimed at people who are operating this on a daily basis. So you really need to understand how that works for, whether you're looking at the infrastructure certification exam or the data engineering exam. It's certainly not something that you could do in a weekend, for example. Right? So I mean, the formalized training on Quick Labs, you're looking at a week for architecture and a week for data engineering, but really you'll need follow-up after that as well.
Yeah, I think the labs involved, obviously the pace that you go through those is down to the individual, but it's really important to have that hands-on technical knowledge rather than just the theoretical from the courses. So very important. Great, that was it for the questions, so thank you very much.
Great, thank you, Richard. So please provide feedback on the left if you haven't already. And just in terms of more resources, so we talked a bit about certification. We do have some links available here, so you can look at what it takes to get certified. You can look at some hands-on labs. You can look at things like Coursera for additional training. And remember that really the best thing to do is just to start playing with it. And we do have free tiers available, so cloud.google.com/free. So you can just log in with a Google account, spin up a server, and see how it works for you. So please stay tuned. In a few minutes, we've got Dambo coming up to talk about Compute Engine in depth. So again, there were some questions around migrating applications. So hopefully Dambo will give us some better insight on how we can do exactly that. So great, stay tuned.